Welcome. So in the last couple of videos, we have been talking a lot about data types. We talked about how they're represented inside of the computer, and a lot of these discussions were the result of when we talked about arithmetic operators, specifically because we were able to mix these data types together with these operations. And then we talked about data type sizes and how these sizes had certain limitations, and therefore we had to do certain things with negative numbers and 2's complement, and we talked about all these things. And in this video, which is the last video that we're going to be spending on talking about data types and what happens with data types and information for a while, is going to be a particular problem, a particular error that does not have a workaround. Is something that we have to deal with and we have to take into consideration when we're dealing with mathematics in our programming language, and that is the problem of overflow and underflow. So let's get started. So perhaps you have heard of this problem before, of overflow and underflow, and this problem occurs in many different scenarios. So this particular scenario has to do when we deal with numbers. Now, if we look at this table, which I've been using in the last couple of videos to talk about the data types and how long they occupy in space and what is the numeric range that they represent, you will realize that, yes, of course, char has a range of negative 128 to 127. But okay, so I told you what you can represent. But what happens if you don't follow these rules? What happens if you say, well, I want to store the number 500 in the data type char? Okay? I mean, I haven't said that there is something stopping you from doing that. So when you do that, and we saw this in the video of unsigned and signed integers, and then we saw it again in the video when we talked about short and long integers, we started to get a very weird number when we started to put a number that was not part of this range. So to take a look at that, let's go look at the data type char, which is the one I've been using throughout these videos, mainly because it's easier for me to write here on this board. But again, this applies to integers, short integers, regular integers, long integers. So I'm going to draw this little box. Think of this box with 8 compartments as a byte, right? So this is where I store 1 byte. So if I want to store the number 127, well, we said that 127 looks something like this: 0, 1, 1, 1, 1, 1, 1, 1, right? And so then I can put each byte in their corresponding slot, and I am able to fit the number 127 into this byte. Okay, so now you want to put a higher number. You want to put the number, let's say the number 500. The number 500 in binary, how does it look? 1, 1, 1, 1, 1, 0, 1, 0, 0. And so just like on the top, I'm also going to create another byte compartment, right, where I'm going to put this 7 bytes. So here we have 1, 2, 3, 4, 5, 6, 7, 8. And if I try to store this bytes, well, this is going to go here. This is going to go here. Then this is here, 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 here. This one goes here. Where does this one go? C++ assumes that the user, or the programmer, us, understand that char can only fit 8 bits. And so if you try to store something greater than that, what C++ does, it says, okay, well, you're giving me something that I can't fit in 8 bits. So whatever I can't fit, I'm just going to toss it away. So what ends up happening is that the number 500 becomes this new byte, which is 1, 1, 1. We say 1, 0, 1, 0, 0. This is what? This is the sign bit. This number is supposed to be a negative number. So this number right here, it actually is what? It's a negative number that is represented in 2's complement, like we explained on the previous video. So this number is actually negative 12. Certainly 500 is not negative 12. So what happened here is that we had an overflow. So imagine you have a cup of water, you fill it to the very top, and then you add a little bit more water. What happens to that extra water? It spills. You lose it. Well, same thing here. If you try to store something bigger in a data type that is smaller, well, whatever is left over is just going to spill. It's going to be thrown away. And whatever is left, that's what we have. And it just so happens that when we talk about numbers, whatever we have, well, that changes significantly. So why do we care? Maybe you say, okay, Daniel, I know what are the ranges because you gave me this fancy table. Why will I care? I mean, I just know which numbers I'm going to use, and I just use the appropriate value. I use the appropriate integer, right? If I'm going to be in the thousands, then I can do a short int. If I'm going to be less than 100, I use a char. I don't have to worry about this. Well, actually, you do, because there's another problem, and that is mathematics. Let's take the following example. Let's say that I want to add 100 plus 99. Why not? I'll just make those up right now. 199, right? Okay, so let's do this in binary. Now assume that we're using a char. So let me write here a char. So we're doing a char data type, right? So 100 using a char looks like what? 0, 1, 1, 0, 0, 1, 0, 0. And the number 99 in binary looks like what? 0, 1, 1, 0, 0, 0, 1, 1. Okay? Now let's do this addition. Well, 0 plus 1 is 1. 0 plus 1 is also 1. 1 plus 0, that's also 1. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 1 is 0, and we carry a 1. 1 plus 1 plus 1 is a 1, and we carry a 1. And then this becomes a 1. So the answer should be 199. However, remember, this guy right here, again, that is the sign bit. This number became a negative number. That's not good. That's not bueno. This is, in fact, negative 57. Here we have two numbers that perfectly fit in a char, but an operation that involves the two numbers can yield a result that does not fit in that data type. So when you do things like addition, subtraction, multiplication, division, you have to consider what kind of numbers am I dealing with. And if these numbers are quite significant, and I'm going to be, in particular multiplication, if I'm going to be doing these kinds of arithmetic operations, will I go over this value? And if I do, then perhaps I should reconsider the data type that I want to use, right? So instead of using a char, and I'm going to be doing some extensive math with it, perhaps I should just use int. Or perhaps I should definitely go into a long int. For the most part, again, and I said this on the previous video, I don't want you to be paranoid about what data type should you use. For the most part, you always use the data type that is the most obvious. In this case, if we're trying to represent an integer, you just go with an int. If you are dealing with millions of integers and you are really desperate to save some space, then that's when you can go to a short int. If you are trying to deal with very large numbers, then you go to a long int. And if you're not trying to do math and you're just trying to represent values, kind of how we represent characters with char, and you only have a fixed number of values that is less than 255, then you can go with a char. However, the moment that you start involving mathematics, you need to remember that it is possible that if you're going to be dealing with very large numbers, that you could cause it to be an overflow. Okay, so that sums up what an overflow is. And lastly, because I said in the last video that I was going to talk about this, I mentioned that when we do 2's complement, we flip the bits and then we add 1. And that sometimes when we do that, we get a little carry. So I had the example of 2 minus 1, which I said is the same thing as 2 plus negative 1. Well, it's a plus, right? And then this right here in binary, after we do the 2's complement, well, 2, it just looks the same, right? So 2 was 6 zeros, 6, and 1, and a 0. And then negative 1 in 2's complement was just a bunch of 1s, 8 1s to be specific. And then once we did the addition, this gave us 7 zeros, 2, 4, 6, 7 zeros, and a 1, right? Because the result was supposed to be a 1. But then, once we started doing the addition, like let's say we did 0 plus 1 is 1, 1 plus 1 is 0, and then we had a bunch of carries. And then at the end, we had this 1 carry that came out. This, in a way, might appear as if it was an overflow, but it indeed is not an overflow. And this is because, Remember, we represent negative numbers using 2's complement, and by using 2's complements, we're flipping up the bits, and it just does something completely different. So in this case, we don't really care about this little floating carry or this little floating number that was carried out of this addition. However, we're able to tell that an overflow occurred by looking at the sign bit. So if you add two numbers, one that's positive and one that's negative, it will never lead to an overflow. And this is simply because you have a number that's bigger in the positive side, a number that's bigger on the negative side. Once you put them together, you're going to get a smaller number that will have the side of whichever of the two had the largest magnitude. This only occurs when you have either two positive numbers or two negative numbers. So when you subtract two negative numbers and the sign bit becomes positive, then you know you had an overflow. If you had two positive numbers and you added them and you got the sign bit to be a 1, then you wrap over to the negative side, so you had also an overflow. So this is why we don't pay attention to this carry that comes out from the addition when we do 2's complement. Now, there are ways that we can check, that we can say, hey, did an overflow happen when we did some mathematical operation? And we will talk about that more in the future because it will require for you to understand a few other concepts before we can move there. However, there are ways to check and we'll talk about it in the future. But for now, just know that when you're dealing with numbers, you could cause an overflow. Okay, so we talked about overflow. What is an underflow? Well, an underflow affects particularly the floating numbers. So an overflow was your number, the magnitude of your number was so big that it wrapped around. It went from being positive to negative. Or the other way around. It went from being negative to positive. However, an underflow is when your number starts to get so small that your data type can no longer represent it properly. So remember that here on a float, we have 7 digits of precision, right? So from the period to the right, we can represent up to 7 digits in an accurate way. If we try to get smaller than that, we are going to start to get issues. So an underflow happens when from an arithmetic operation, let's say you have a number, let's just write a little quick example. Let's just say that I have 0.0000001, right? So this is, let's make it a little bit smaller, 1 right here. So this is 6 digits of precision, and I'm going to multiply it by itself. Well, what this is going to cause is it's going to make this number very, very small. This will actually look something like 0 point, and then it's going to have like 11 zeros. So that's 5. Let's write another 5. Let's see, 2, 4, 6, 8, 9, 10, 11 zeros, and a 1. Notice that I have two values that I can properly represent with a float number. But now I've gotten so small that I no longer can do that. So this is called an underflow. Okay, so it's the same idea, but with floating numbers when we're talking about very, very tiny numbers, and you get tinier as a result of an arithmetic operation. From this video, what I want you to get is that we have a problem when we deal with numbers, and that is that we can overflow or underflow when we do this type of numeric operations. And we should have in mind that if we're going to be dealing with this magnitude of numbers, that we use the proper data type so that we're able to represent our numbers properly without any issues. Okay, if you have any questions, feel free to leave a comment below. If you like this video, you found it useful, leave a like if you don't mind. If you're new to this channel, check out the video series, check out the channel if you like what you see. Subscribe, be safe, and peace out.